Hey, so I wanted to go over the test review for those of you who won't be able to um, see us go through it. So start off with number one and number two. We're just graphing them. So I like to make a t-chart for this. So if I make a t-chart, you want to pick numbers that you can easily plug in to the problem. So if I look, I just have the square root of x that I have to worry about. And then I'll subtract 3 from the square root of that each time. So I can plug in 0, 1, and 4. We don't want to plug in 2 because I don't know what the square root of 2 is. And can't plug in negative 1 because I can't do the square root of negative 1. So if I plug in 0, square root of 0 is 0, minus 3 is negative 3. Plug in 1, square root of 1 is 1, minus 3 is negative 2. Plug in 4, square root of 4 is 2, minus 3 is negative 1. So I'm going to graph those 0, negative 3, 1, negative 2, and 4, negative 1. And then just connect them. We put a little arrow on the end. We're not putting an arrow by the negative 3 because I can't go past this because of the negatives. So my domain, remember, is your x value. So my furthest to the left x value was 0. Furthest to the right was infinity. It's going to keep going because of that arrow. My range, my lowest point was negative 3. My highest point, again, infinity because of the arrow. For number 2, again, make a t-chart. This t-chart is going to be a little bit different because if I plug in 0, 0 minus 1 is negative 1, can't do the square root of negative 1. So I'm going to choose 1, 2, and 5 for this one. So 1 minus 1 is 0, square root of 0 is 0. 2 minus 1 is 1, square root of 1 is 1. And plug in 5, 5 minus 1 is 4, square root of 4 is 2. So I'll point at 1, 0, 2, 1, and 5, 2. So it's going to look like that. So the domain, the furthest left point was 1, and it goes to infinity. And my range, the lowest point was 0, and again goes up to infinity. Okay. Most of the test will be simplifying expressions. So that's also most of your review. I did include some stuff from the e-learning days. So here I have the square root of 36, which is 6. Then I have x squared. That's even, so I can just divide it by 2. 2 divided by 2 is 1. So I just have 1x. So it's just 6x. Done. Number 4, square root of 50. So I'm going to factor 50. I'm going to choose 25 and 2. Remember, we're looking for numbers that you can take the square root of easily or prime. So you can take the square root of 25, 2 is prime. So I have square root of 25 times 2. And if you want to break that apart, you can, but you don't need to. Square root of 25 is 5. Bring down your square root of 2 because I can't do anything with that, so that's your answer. If you had chosen, say, 5 and 10 as your factors, that's fine. You just have to factor it a bit more. 5 is prime. 10, you have 5 and 2. So this would have factored into 5 times 5 times 2. Remember, you want to look for pairs. So 5 times 5 is 25 times 2. So we end up where we were over here. So if you just go a different route, just look for combining pairs together. Number 5, I'm going to ignore this 2 that's out in front for now and just do the square root of 20. 20 I'm going to factor into 4 and 5, which both are numbers that I can use. Now I'm going to bring down the 2. I have the square root of 4 times 5. So 2 times the square root of 4 times the square root of 5. So 2 times the square root of 4 is 2 times the square root of 5. Can't do anything with that. Then 2 times 2 is 4. So your answer is 4 square root of 5. Number 6, with multiplication, you can combine unlike terms. So we're going to actually multiply those together to get square root of 18. 18 can factor into 9 and 2. So that's square root of 9 times the square root of 2. Square root of 9 is 3. Can't do anything with the square root of 2, so bring it down. So the answer is 3 square root 2. And a way to check this, if you do 3 times 3, you get 9. 9 times 2 is 18, which is what I wanted. Number 7, it's multiplication. So again, we can combine unlike terms. 2 times 3 is 6. Square root of 3 times 12 is 36. Now this one I can easily do the square root of 36. I know the square root of 36 is 6. So really I'm just doing 6 times 6, 36. So that's my answer. Number 8, I'm going to first factor my 20, which I already did up here. I know that 20 factors into 2 square root 5. So I have 2, and then I have square root 5. I'm separating it a bit because I know I have some variables, so I might have some variables there. So x, there's only one x, so that's going to stay under the square root symbol. And y cubed, that's odd, so remember our trick is subtract by 1, so that's y to the second. Divide that by 2, so y to the second divided by 2 is y to the first, so just y, that's going to go out in front. Since I had to subtract 1 since it was odd, we have 1 left on the inside. So remember, if you have an odd exponent, you will have exactly 1 variable left on the inside. For number 9, it's just x to the 9th. That's odd, so I'm going to subtract 1 to get x to the 8th. Divide that by 2 to get x to the 4th. And then put that 1 that we subtracted back on the inside. Number 10, we can just combine our like terms because this is addition and subtraction. So this is kind of like 4x minus 3x plus 3x. Just instead of x, it's square root of 3. So really I'm just doing 4 minus 3, which is 1. 1 plus 3 is 4. And then stick the square root of 3 by your answer. Number 11, this one's kind of weird. I can factor 6 into 2 and 3. And then minus 48. You could factor into 16 and 3. I know some people chose 6 and 8. That's fine. Just do what you did up here where you combine your pairs. So I have square root of 16 times 3. Now I can separate them, but I notice here there aren't any pairs, so I know I'm not going to be able to really do anything, so I can rewrite that as 2 square root 6. The only reason why I separated it was just to be sure that I couldn't do anything. Minus square root of 16 is 4. Can't do the square root of 3, so this is your answer. So since those were not like terms, square root of 6 and square root of 3, we can't actually combine those, which is why we keep them separate. Okay. Then on the back, these 3 we're going to solve. So remember, we always want the square root part to be by itself, so I'm going to add the 10 to the other side to get square root x equals 10. Once you have the square root symbol by itself, you just square both sides to get rid of it. So we're left with x equals 10 squared is 100. So that's your answer. Number 13, my square root symbol is already by itself, so square both sides to get rid of it. So we get x plus 2 equals 6 squared is 36. Subtract 2 to get x equals 34. 14 is tricky. We already have the square root symbol by itself, so we can go ahead and square it. But when you square the right side, since there's more than one term, we need to square it all together. So you get x plus 4 equals, now x minus 8 squared, I'm going to have to use FOIL off to the side. So x minus 8 times x minus 8. So x times x is x squared. X times negative 8 is negative 8x. Negative 8 times x is also negative 8x. Negative 8 times negative 8 is positive 64. Combine like terms to get x squared minus 16x plus 64. Now, so I'm going to take this and bring it over here. Now I'm going to combine like terms, so I'm going to subtract this x over and the 4 over to get 0 equals x squared. Negative 16x minus x is negative 17x. 64 minus 4 is 60. And then I want to think, what two numbers can I multiply by 60 and add to get negative 17? Well, that's negative 12 and negative 5. So I got x minus 12 and x minus 5. And then just put both parts equal to 0 and solve. So x minus 12 equals 0 would give me x equals 12. And x minus 5 equals 0 would give me x equals 5. So that one had 2 answers because of the foiling that we had to do. Okay, moving down to Pythagorean theorem stuff. So here I want to know if these are going to form right triangles. So always make sure that your biggest number is your C. So this would be our C. I did put them in the correct order though. So we could do 6 squared plus 8 squared equals 10 squared. So 36 plus 64 equals 100. And 36 plus 64 is 100. So since they were equal, we can say yes, that would be a right triangle. 16, again, this would be my C because it's the biggest number. So 2 squared plus 3 squared equals 4 squared. 2 squared is 4, 3 squared is 9, 4 squared is 16. 4 plus 9 is 13. 13 does not equal 16, so no, this is not a right triangle. Okay, 17 and 18, we're just solving the Pythagorean theorem. So this is my C, so I'm going to use my 16 as my A. So 16 squared plus 12 squared equals C squared. 16 squared is 256. 12 squared, 144. 256 plus 144 is 400. And then to figure out what C is, you take the square root of that. So the square root of 400 is 20. So C equals 20. Number 18, this time they give me my C. So I could either solve for A or B, doesn't matter. I'm going to say that this is my A. So you have A squared plus 13 squared equals 20 squared. A squared plus 169 equals 400. Subtract the 169 to get A squared equals 231. Take the square root of that and you will be able to use a calculator to get about 15.2. Okay, so if you have any questions about that, let me know. Email me and I will help you. Tuesday will be a review day and then your test will be Wednesday.